Assalamualaikum to our lecturer, Madam Bushra binti Latif. Today, me and my group are going to present our group project, which is the correlation between study hours and GPA by using least square solution. So this is my group members. My name is Awatif Sufiah binti Zulhazmi and I am the first presenter. My other members is Syaza binti Raimi and Aisyah binti Salahuddin. So let's move to the next subtopic, which is introduction. Nowadays, academic achievement among undergraduate students is influenced by various factors, including study habits, time management, and individual motivation. While it's commonly believed that more study time leads to higher grades, research presents mixed findings. So, we would like to see if there is predictable relationship between GPA and study hours. Hence, the least square method will be used. Least square method is a form of mathematical regression analysis used to determine the line of best fit for a set of data, providing a visual demonstration of the relationship between the data points. Next, the following is a data table that includes grade point average GPA of student and number of hours students study per week. For our literature review, least square approach involving minimizing the sum of the squares of the offsets, residual component of the points from the curve to get the best fitting curve or line of best fit for a group of data points. The trend of outcomes is statistically estimated throughout the process of determining the relationship between two variables. There are three types of least square model that we choose for this project, which are linear model, quadratic model, and cubic model. For linear model, first we set up MV is equal to Y, where M is study hours per week in hours and Y is GPA. Then, we construct the normal equation of linear model. Lastly, we can obtain the least square solution, which is 3.512543 and 0.004561. So, the best fit linear curve is y equal to 3.5125 plus 0.0046x. After that, we can find the error vector for this equation. Then, we can obtain the magnitude of the error vector, which approximates to 0.4418. Lastly, this is the linear graph of best fit linear curve and error vector against study hours.
Next, let's test our data into the quadratic model. So at first, we can have M, which is the first column have 1, the second column have X, which means study hours, and the third column is the X square. Then we can find V equal to A, B, and C. And then we have Y is the GPA that we got from the raw data. And from MVY that we got, we can produce the normal equation and the least square solution. From what we got earlier, we can also find for the error vector. The error vector equation is E equal to Y minus MV. V is the least square solution that we get. Then from the error vector, we can get the magnitude error vector. The magnitude error vector is equal to 0.4437. Then we also plot two quadratic graph, which is graph of best fit curve and graph of error vector against study hours. Like we can see for the graph of best fit curve, we can see the graph produce the quadratic curve with equation 3.3914 plus 0.0198x minus 0.0003x squared. And then for the graph of error vector against study hours, we can see that the red dot is scattered normally, and that means our model is mostly accurate.
My name is Syaza binti Remy, and I will be explaining the cubic model. First, we set up the data in the equation of mv equals to y, where the first column of m is 1, the second column is the x values, the third column is the x squared values, and the fourth column is the x cubed values. Next, we construct the normal equation of cubic model as shown. Lastly, we can obtain the least square solution, which is 3.110038, 0.07786, negative 0.0035395, 0.000470096. Thus, the best fit cubic equation is y equals to 3.110038 plus 0.0778556x minus 0.0035395x squared plus 0.000047x cubed. Then we can find the error vector of this equation, and we can obtain the magnitude of the error vector, which is approximate to 0.4183. Lastly, these are the graph of the best fit curve of the cubic model and the graph of error vector against study hour. Based on all of the model, the following approximation of the error magnitudes are obtained as shown. In conclusion, the best fit curve in this case, which will give the best approximation, is the cubic model, since it has the minimum magnitude of error vector. That's all from us. Thank you.
The last one is reference. The data we used in this analysis was obtained from the Kaggle website.